Good evening. I'm hoping that we're going live. I just need to check. I've had a few little technical issues, but let me know if you're there in the chat, or if you've got any problems you want to look at. And I'll be getting started soon, so we'll see how that goes. I've just got a bit of a problem with trying to link my phone here, so I don't know what's happening. We'll just see what's going on, see if we can get it to work. I may not be able to get it to work, in which case I'll see what happens. See what's going on here. So just give it a couple of minutes. If you are there, that's all good. Otherwise, we'll just try and resolve it. Microsoft just sending me a code at the moment, so doesn't seem to be wanting to cooperate with me. Let's see what we can do. Hang on, just there. So things don't always go well. Okay. What have we got there? 893614. Okay. Everything's all good. And we'll just try this last one there. No, not having a bar of it. Looks like it. Never mind. We'll try and sort that out for tomorrow. So we'll drop that out of there, and we'll just what I'm going to do now is just check that my sound's going all right, and we'll see how we go. Looks like I'm in the right YouTube channel anyway, so that's always a bonus. There we go. And now what do we got here? View channel. Right, live. Okay, yep, and I'll just check that we've got a bit of sound. What's happening there? Do we have sound? I've got my head down. Sound. There's a bit of a lag, so I've got to work it all out and see how we go. Not quite sure what's for some reason I don't seem to have any sound. Not quite sure what's. Oh, yep, we're all good. Looks like we're okay. So, yep, we're live, and it's all happening. All good. Okay, all right. But I don't have my phone tonight. All right. Oh, yeah, and that's what's going out there. So that's good. Okay, well, Good evening and welcome to Maurieo Maths in Real Life, episode 3. A bit of a poor start tonight. Technology let me down. So the other night I had my phone there, and I was able to have access to that, but it doesn't seem to want to do that tonight for some reason. Phone link is not working, so it's doesn't want to do that. Right, so okay. Yeah, so we'll give up on that, and let's get underway. So last night I talked about just some simple mathematical concepts, and something along the lines of that 3a equals say for instance 3a equals 15, and so if 3a equals 15, what does 1a equal? Well, 3, that means 3 times a equals 15, so we divide by 3. So, and I think I was just going here, divide both sides by 3, because we know that it's an equation, an equality situation. So we've got to keep it equal. And so if we add something to one side, that'll make the other side go out of balance. So, and it's not only adding, but if we multiply, if we take the square root of both sides, a lot of different things that we can do. And there's things that we do the inverse, and that gives us sort of advantages. So we've got these names and things like that. So what we do with this one is divide both sides by 3. And as we can see there, one way that we show this is just to say that the 3's, they cancel out. So we can put a 3 divided by 3 is 1. And if you remember from first night, if we multiply anything by 1, it doesn't change it. So 1a is the same. And in fact, can be very confusing. Sometimes we write a on its own, but in fact it means 1a, but because we multiply 1 by a, it doesn't change it, we just write it as a. So yeah, we get that sort of situation. Now 15 divided by 3, we can say that a, let's have that in black, a equals 15 divided by 3 is 5. In this particular instance. Now, and if we wanted to do a check, just to check that that's right, and last night I had ChatGPT available to do some checking with, but, well, I don't have it exactly there tonight. I could use it on my screen, but I haven't got that set up. Well, I have, but we don't need it tonight anyway. So, well, so far. So check, if we say, let's say a equals 5, we go back to our original thing. So 3 times 5, and 3 times 5 is 15. So that's a good double check. So we substitute back into the, in mathematical things, we substitute back into the original equation 3a equals 15. 3 times 5 equals 15. Therefore, a must be 5. And yeah, so that's pretty good. So that was just a recap of what we did last night. And we also looked at square roots. So if we said, let's try something else. Let's say b squared equals 64. B squared equals 64. So what is b? Well, the square root b squared equals b times b. All right? And the square root of b squared, the square root of b squared is b. Okay? So the square root of b squared is b. All right? So if we take the square root of both sides, so this is what we're going to do here, square root both sides. So like that, and we'll come down to here. Square root of both sides, square root of b squared equals square root of 64. Now the square root of b squared, what number multiplied by itself is b squared? Well, b, of course. Well, I told you that in there anyway, but that's what it is, square root. So the square of a number is just the number multiplied by itself. So what number multiplied by itself equals 64? That's the square. And if we want to find the number, we'll just take the square root of 64. So square root of b squared is b, and the square root of 64 is 8, which is, that's the answer. B equals 8. If we want to do a check, so we can say b squared, which just means 8 times 8. Okay, and that means 8 times 8 equals 64. So we've got that good check. So as I said last night there, that if we let people know what we do, tell people what we do the check at the end, we're really showing people that we know what to do, and we're proving what it is. So that gives people confidence in our work, and it shows that hey, this guy knows what he's talking about. So yeah, those are two ones there, and you'll notice that typically we start with addition, but I've started with multiplication, which is 2b and b squared. Now, just a little something. If we let's take sort of what did we have here? 3a, and we said 3a. Let's have a look at that now. It must be in the nature of the human condition. I feel that we name things. We give things names. So here we are. We've got this 3a, from that previous equation there. 3a equals 15, and we've got to give everything names. So let's say we call a, that's the variable. The variable, because it varies. That's an I. Variable. Because it varies or it changes. Now this will the A can be any number in this instance, so that's the variable, but the 3, we call that the constant. The constant. Or sometimes the the coefficient, or no, that's wrong. Why am I keeping on going with it? Not the coefficient. It'll come to me, but it's the constant term there, or the sort of the prefix, not the coefficient, but yeah, but it's a number, and it doesn't move. It's constant. It sort of stays there. Yeah. I'll come back to that. I haven't, maybe could do a better job of that. But yeah, we'll work with that one. Okay, so the variable and the constant. It's slipped my mind. Okay, so now let's have a look at some addition. So let's say we just have, and we'll keep it quite simple, let's say we just have an example such as, I struggle keeping my consistency there. Let's say A plus 7 equals 10. So a number plus 7 equals 10. Ooh. So we start with a number. So one of the things that we can do, one of the options that we have is one called guess and check. Guess and check. So we could just guess A plus 7 equals 10. Well, it's got to be less than 10, doesn't it? No, it's going to add 7. I don't know. Let's try 4. Okay, try 4. And so we can substitute the 4 back into the A, for the A, and we get 4 plus 7, and that equals 11. So, no, it's not equal to 10. So therefore, A is not 4, that's 1 too many. So we'll just go 1 less. And we get 3 plus 7 equals 10. Yeah. So that's guess and check. We can just try, but we can do better than that. We can do better than that if we look at it. And it's this whole thing. If you imagine the balance and you've got A plus 7. So imagine that you've got a kid, like a little kid, and let's say it's, a little kid, and, or no, say it's a sparrow or something. Say it's a bird, a little sparrow, and then you've got 7 starlings, 7 blackbirds, and a little sparrow sitting on the one end of the seesaw, and that's equal to 10 10 starlings or something. Yeah, no, you've got 7, a number of birds plus 7 starlings. Oh, it's not a very good example, is it? And that equals 10. So if you take away the 7, right, the other end's going to go down. It's going to go up because it's going to become unbalanced, right? The balance is so. So we've got to take, if we take away 7 from both sides, let's do that. Okay, take 7 from both sides. So we can say A plus 7 minus 7, and what we do to one side we must do to the other, equals 10 minus 7. So we get A plus 7 minus 7, that leaves 0. So that's A, and 10 minus 7 is 3. A equals 3. So take 7 from both sides, or in mathematics we sometimes say add the inverse, or so we add negative 7, but simply you just take 7 off both sides, and there you are. You find out what A is, and then you can do a check. Okay, you can do a check, and you can put in for A, so you get 3 plus 7 equals 10. Oh yeah, all good. That's awesome. Okay, so what you do to one side, got to do to the other. All right, so let's try another one. So let's say C plus 16 equals 22. Okay, C plus 16 equals 22. How do we do that? Well, let's see, plus 16, so we'll take 16 off both sides. Now, I'm going to say take away or minus 16 from both sides. So now we get C plus 16 minus 16 equals 22 minus 16. What you do to one side, you must do to the other. So do to one side, you must do to the other. And so C plus 16 minus 16 just leaves C on its own. 22 minus 6 is 6. Oops. Just stay there, you. Equals 6. Let's do a check. So we substitute back in the original equation. C6 plus 16 equals 22. Oh, yeah, that's all good. We got those done. Now, but what happens if, what happens if it's D minus 3 equals 2. D minus 3 equals 2. My takeaways. Well, when we had C plus 16, we took away 16. Now here we've got D minus 3. Well, how about we just add 3 to both sides? Let's see what happens. Plus 3, both sides. Okay, so let's try that. D minus 3 plus 3 equals 2 plus 3. And we got D minus 3 plus 3, D equals 5. D equals 5. So what the hell's... There you go. Is that all right? Is that going good? Let's. I'll just see if I can hook up here again. Don't seem to want to. No. Doesn't seem to want to. Yeah, doesn't seem to want to connect up. Never mind. Okay, I'll keep going. So D equals 5. Let's check that. CHK for check. Substitute back in the original equation. 5 minus 3 equals 2. So what we can see here is that if we C plus 16 equals 22, if it's plus, we take minus from both sides. If it's minus, take away, we add to both sides. Pretty simple stuff to keep that balance, keep everything in balance. That's the importance. That's the important thing. Keep everything in balance. All right, so now we have some interesting problems because, right, what about if, let's say we had D plus 7 equals 2. D plus 7 equals 2. Okay, so let's apply our rules. Let's apply our rules. So we said if it's plus, we take 7 from both sides. So minus 7 both sides. So we get D plus 7 minus 7 equals 2 minus 7. Right. D plus 7 minus 7 equals 2 minus 7. So that's D equals 2 minus 7. And that equals minus 5. Okay. Can we do that? Can we do that? Minus 5. Well, turns out we can. Negative numbers. Think of a lift. Think of a lift. Okay. And here's the ground floor. 0. And 1, 2, 3, 4, 5. It might have some basement car parking. Okay, and then it might have some stories in the building. 1, 2, 3, 4. So imagine that that you're at level 2. Okay, that's where you're at, and you've just come up 7 floors from D. So you go 1, 2, 3, 4, 5, 6, 7. Okay, so you've just come up from 7 floors and you're on the 2nd floor. So you parked your car on the 5th floor below ground, and then you've come up 7, 1, 2, 3, 4, 5, 6, 7, and now you're on car park 2. So, and like it works with temperature and things like that. So we have, yes, we have negative numbers. And maybe we'll have to have a look at those in more detail, perhaps. Well, we can have a look. So we have what we call the number line. Okay, that's 0 there. 1, 2, 3, 4, 5, 6, 7. I'll just do that. 1, 2, 3, 4, 5, 6, 7. Okay, and then here we've got -1, -2, -3, -4, -5, -6, -7. So this is called the number line. And so in this case here, we're at, we started at, we were at D. We were at 2 here. We started here, and that was we're going backwards. So we went -7, 1, 2, 3, 4, 5, 6, 7, -7, and we end up at -5. So when we go minus, we go to the left, minus, and if we want to go, if we add, we go to the right. So if we wanted to check that out, our answer was -5, -5. We go 1, 2, 3, 4, 5, 6, 7, and yeah, we go -5 plus 7 equals 2. And so this is called the number line. The number line. Number line. Okay, so that's our number line. Working away there pretty much for us. So, yeah, we've got a little way there. So we can solve simple little equations now where we've got, we've got ones with like we had 3a equals 21. So we divide through by 3, divide both sides by 3, and we get a equals 7, which we check. 3 times 7 equals 21. So we've got ones like that we can do. And we've got ones like a plus 5 equals 6. So then we minus 5 both sides. Okay, so we get a plus 5 minus 5 equals 6 minus 5. A equals 1. Check. We get 1 plus 5 equals 6. Yep, that's all good. Yep, that one there is all good. So we can do those two simple ones. All right, now, and maybe we'll start to have a look at this tomorrow night, but something to think about. We've got 3a plus 5 equals 26. 3a plus 5 equals 26. Something to think about for next time. Okay. A equals, and we'll work on that. So I started a bit late tonight at 8:38, so with a few technical difficulties in that, so just half an hour. Remember, my working sort of one of the things I say about maths is a little often. All right, this has been a Maurieo presentation recorded live in our lovely little studio in downtown Ngaruawahia. The Big Smoke in Aotearoa, New Zealand, a place where Kiwis live in a paradise we like to call God's own country. All good? Send me your problems if you've got them. Cheers, good night, and good gardening to you all. Bye.